Thanks, Sebastian. Thank you. Good morning, everybody. I'm aware that most of you are listening in a second language. I have a huge amount that I want to pack into a short amount of time. So what I'm going to do is speak very quickly. I'm sure it's going to be fine. So, yes, picking up on what Sebastian said, this is a new talk about some very old stuff. Is probably the best way to describe this. CUPID is an acronym. In fact, the technical term is a backronym because I made some things fit so that the word worked. And I came up with this as a result of a sequence of events. So let me tell you about the sequence of events. A few years ago, I was in a pub, as Sebastian says. I was actually in a small event called PubConf, and PubConf is brilliant. It's an anti-conference after like a big formal conference. And the idea is that you get a bunch of the speakers who are at the conference in a pub, and they all do a 5-minute lightning talk, like an Ignite style, 15 seconds per slide, auto-forwarding, auto-advancing slides. And you get 5 minutes, and there's lots of beer involved, and people vote by shouting and yelling and banging glasses, and someone wins. And so I gave a talk at PubConf in 2017, which is about 100 years ago now, about Solid. And in particular, so I structured the talk and I said why every element of Solid is wrong. Now, this was clearly tongue-in-cheek. It was clearly just poking the bear. And the reason I did this, it was completely pragmatic. It was that I had to come up with 20 slides because that's how a 5-minute talk works. And I figured if I have 5 elements of Solid, then that's about 3 slides per thing, one to say what it is, one to say why I don't like it, and one to say what to do instead. Basically, the talk writes itself. So I did this talk, and a bunch of software craftsmen came after me with pitchforks, is what happened. Anyway, so I put the slides online, and every now and then they pop up on Twitter. And about a month ago or so, I was invited to an Extreme Tuesday Club. Now, Extreme Tuesday Club, XTC, runs in London. It's virtual now. XTC, I believe, is the world's oldest XP, Extreme Programming Meetup. It's been going since about 2001, 2002, something like that. So it's been around for a long time. It's moved pubs, but it's always stayed somewhere in the city of London. And now, as I say, it's from people's homes. And they were having a topic on Solid. And one of the organizers knows me, and he said, Daniel, we're talking about Solid. You did that thing a few years ago. Do you want to come and speak about it? So I came to this meetup, and it was lots of really lovely people. If you can get to XTC, wherever you are in the world, it's brilliant. And so then they said, so the organizer said, look, if you're going to bash Solid, I'm not going to bash Solid. I just think it's had its day. If you're not a fan of Solid, what would you replace it with? And I thought that's a really good challenge. So I came up with a thing, and that's CUPID, what I want to talk about today. And so then he said, would you like to? And he said, I'm going to write up this meetup. I'm going to blog it. Do you have a reference online to CUPID? I was like, no, I don't. I'm really disorganized like that. So he said, okay, can you write something so I can point to it? So I wrote an article. I started writing up CUPID. The introduction itself was about 2,000 words. So I just posted that, which is like the backstory to CUPID. And that blew up, it turns out. It ended up on Hacker News and all sorts of places. And so then, completely coincidentally, Sebastian reaches out and says, hey, we're doing this JAX Online thing. It'd be great to get you along. I said, oh, Sebastian, I've been talking about this CUPID thing. And he said, great, that'd be a really fun topic. So now I have a deadline, right? And so the deadline is now today. So May the 4th be with you. Happy Star Wars Day. And let's take a look at why CUPID and why joyful. So I want to start with a question. Who are we writing code for? We're programmers, we write software. Who are we writing code for? My favorite take on this is Martin Fowler this is like from 25 years ago. This is from the original refactoring book in 1996. He says, any fool can write code that a computer can understand. Good programmers write code that humans can understand. And I read this in 96 or whatever, and wow, of course, we're writing code for ourselves, for each other. And so then I thought, well, okay, but that's great, but can we do better than understand? Now, around the same time, Richard P. Gabriel, famous software thinker and pioneer, he's writing a series of articles. He talked about habitability. And I've got to name check Kevlin Henney at this point because he's the person who introduced me to this idea of habitability. Habitability, says Dick Gabriel, is the characteristic of source code that enables, and then he says a whole bunch of people, to understand its construction and intentions, and this is the main bit, to change it comfortably and confidently. How often are you in code and you genuinely feel comfortable and confident changing it, right? And he says, habitability makes a place livable, like home. That really resonated with me. So I thought habitable sounds better. What about joyful? What about joyful? Think about a code base that's joyful to work with. Hopefully, at some point in your career, you may be early in your career, you may have been around for a while, you have worked on or are working on a code base that just makes you happy, right? You're happy because you know your way around. You're happy because you can make those changes confidently and comfortably, as Dick Gabriel says. So I was thinking about joy, okay? And this is why solid didn't really resonate with me. It doesn't describe joyful code. I thought, well, can we describe what makes code joyful? Is that possible? Okay. And then I thought, well, okay, if we were going to describe it, what kind of properties would joyful code have? And then maybe we could describe it in terms of properties. I'm very deliberate about my choice of words here. So properties rather than principles. Okay, so solid is, in actual fact, solid is only the first 5 principles in a big list of principles that Robert Martin put together a bunch of years ago. And it was a chap called Mike Feathers who spotted that the first 5 of them, if you rearrange the order, spelt solid. So that's where the idea of the solid acronym came from. So it's not a backronym, it's just coincidental. And it could have been Lloyd's, but that's not a word. So but here we go. So we've got these 5 principles. The problem with principles is this: principles are rules or guidelines. You know, you have the single responsibility. You have one responsibility. Substitutability. You have to be able to act like the thing that you're extending. So they define conditions. They define boundaries, like edges. Okay, and then your code either conforms to the edges, to the condition, or it's wrong. So it's in this binary state. You either have code that's and you see that I watched a conversation unfold on Twitter recently where someone was saying there's a junior engineer who's just learned solid, just out of school, comes into the workplace, sees his first code base, and goes, that's violating SRP. That's violating, and they're kind of going around being legalistic about it all. Properties are qualities, right? They're qualities or characteristics of something. So they define a center. And the idea with a centered property is that you're nearer or further. You're never wrong. You're never like, definitely wrong. It's just that you can always move towards that center. So there's always directionality there. So your code's only ever closer or further from the center. Then I thought, okay, I much prefer properties to principles to describe this kind of thing. What kind of properties would my properties have? We're going to get a bit meta here, right? What kind of properties would my properties have? So the first thing is they need to be practical. Right, I don't want anything esoteric or weird, or I don't want people sitting around stroking their metaphorical beards or scratching their heads and going, "What does this even mean?" So they've got to be easy to articulate. I've got to be able to sit in a pub with Sebastian or with Christina, because I miss pubs, right? I want to sit down with Christina or Sebastian and saying, "Hey, look, let's talk about this thing," and she's saying yes, and it's easy to articulate. So I can say what it is. I can describe it easily. Easy to assess. I can take this thing and say, does this code base possess that property? To what extent does it? So I can weigh up where I am. And it's also easy to adopt. If I decide I like this property, that I think it's a valuable property, a thing to move towards, I can see how I would start moving towards that property. So that's the first thing. It has to be practical. The second thing, it has to be human. What do I mean by that? Again, back to Martin Fowler talking about code for humans. I want these properties to be from the perspective of people working on code, not code. And you'll see what I mean as we go along. And the third thing is I want it to be kind of have some depth to it, some texture. So I don't want these things to be superficial, okay? So it's layered. So if you're a beginner and you come across these things, then you have guidance. Right, I can read this thing and I can go, oh, that sounds useful. I'm going to start striving towards that. But as you're a more experienced engineer, you've been around for a while, it also has layers of meaning, layers of nuance that you can really kind of chew on and apply. And again, we'll see these. So without further ado, here's my take. I'm calling it CUPID. And for me, again, it's joyful coding. It's about the coding experience, right? So the C is composable. So I want code that plays well with others. The U is Unix philosophy. So it does one thing and it does that one thing well. P, predictable. Does what you expect. So predictable, if you can think of predictable as a generalization of testable. Testable is one type of predictability. There are others. I'm going to unpack all of these in a minute. Don't worry. This is what the back half of the talk is about, is explaining what these are. I, idiomatic, right? Does the code feel natural compared to other code? Right? Do I, in terms of cognitive load, is it easy for me to think about this because it's using the same patterns and language and everything else that the rest of my code uses? And finally, domain-based. So is it domain-based in terms of the language it's using, but also in terms of the structure? And again, I'm going to go into that in a bit of detail. So there we have CUPID, composable, Unix philosophy, predictable, idiomatic, domain-based. As my code moves towards each of those things, I find it more joyful to work with that code. When I did come across a code base that has these properties, it makes me smile, genuinely smile. It makes me happy. Okay, so I want to unpack each of these one at a time. And you'll see as well that there's a lot of overlap here. Right? All of these are, in my mind, all of these are desirable properties. There is, as you move towards one, you're necessarily going to pick up elements of the next. So let's take a look at composable. What does that mean? It means this. It means code that's easy to use gets used and used and used again and used again. If it's easy for me to use your thing, I'll use your thing. A great example, a chap called Joe Worms, and he may well appear many times in this talk because he writes CUPID code, right? He wrote a thing many years ago to turn Java objects into XML. And you'd think, well, isn't that a solved problem? Surely we can turn Java objects into XML. There were standards, there were part of J2EE, massive convoluted standards. What Joe wanted wasn't a big XML spec thing. What he wanted was the minimum possible XML to represent the properties of an object so that you could serialize it at the other end, you could unpack it and turn it back into the object. And he wrote a thing called Xstream. Xstream, clever, hey? So Xstream was a streaming library for Java objects into XML. When he first tried to put this onto one of the very early code repositories, like long before SourceForge and GitHub and all that, he offered this library, and the response was, we're not going to host your library. It's too simple. It's too trivial, right? Okay, so it ends up that Xstream is now being used in the International Space Station. Right, I suspect it's probably somewhere in the Mars rover, and because it's so brilliantly simple, all it does is turns Java objects into XML and back again. So code that's easy to use gets used and used and used. Well, let's look at what makes something composable. The first thing is it needs to have a small surface area. So you'll notice that none of my top 5 things are make it small, which you'd think, well, surely make it small. No, make it small is a consequence. Right, so composability is the goal, and small things are easier to compose. Okay, so a small surface area. If something has a small surface area, small APIs, there's less to learn. Right, there's less to go wrong. Okay, so it's more likely that I can trust it, and there's less to conflict. And what I mean by conflict is, let's say it does the thing I want and a bunch of other things. Okay, then. And it turns out that I'm using something else that does one of those things. Suddenly I've got conflict. Suddenly I've got ambiguity in my code. So I want to avoid that. The next thing to make something composable is it needs to be intention revealing. If I can see what it does by its name and its purpose, then it means I can find it easily. Okay, if I want something that, let's stick with serializing, right? I want something that does GraphQL, right? I want a nice GraphQL library, something that's going to make GraphQL easy for me to use. Well, if your library has a nice intention revealing name, I'm more likely to stumble across it. Okay, I'm more likely to serendipitously come across your code. And also I can evaluate it. I can look at it and I can go, this looks like the thing I should need. And I read the README, or I read the incredibly simple tutorial that you put together for me because you're brilliant. And I can tell within 2 minutes that it's not the right fit. So thank you. I really appreciate that, because now I can look at the next thing. Okay, easy to discover, easy to evaluate. If I can find it and it's the right fit, I'm likely to use it. And finally, the fewest dependencies as possible. There's a wonderful quote by Joe Armstrong. This is him talking about object-oriented languages. He says, you wanted a banana, but you got a gorilla holding a banana, and then you get the jungle with the gorilla with the banana. Okay, you wanted a banana, but you got the whole gorilla. And he's saying about all of the runtime guff that OO languages come with compared to something like Erlang, which was the language he designed. But it's so true. I probably the very first open source thing I wrote had some logging in it, and it used log4j. This is about 20 years ago. And Joe, again, he, as I said, he appears a lot. I was working with him, and he said, right, this is a really useful utility. Why have you got log4j in there? I said, well, because I'm logging. He said, what if I'm not using log4j? I was like, why would you not be using log4j? Everyone uses it. And he was absolutely right. If you're using something else, or even if you've got your log4j configured differently, right, then suddenly using my thing has a bunch of unintended consequences. Yeah. So minimal dependencies. Oh man, Node.js is the absolute worst for this. You pull in a tiny thing and suddenly you've got hundreds and hundreds of libraries. Maven, right? I pull in one thing and the transitive dependency train wreck that happens. So Java is only just now getting into compartmentalizing with Jigsaw and being able to have multiple versions. It's taken 20 plus years to get there, not because they're not very smart, because it's a really, really hard problem in dynamically linked languages with big fat libraries. Okay, so minimal dependencies mean you're more likely for me to compose you. Okay, Unix philosophy. Unix philosophy says this: make each program do one thing well, right? And only one thing. So ls, for instance, ls on a Unix lists file details. Here's the thing: ls doesn't know what the file details are. ls asks another thing called stat. Stat knows how to ask a file or a directory or a pipe or some special thing about itself. It can say, how big are you? When were you last changed? When were you last accessed? It can ask it a bunch of questions, and it returns that as some kind of record. What all the ls does, it turns out, is formats the output of stat. But that is so incredibly useful and also quite a big problem, right? Listing things, if you look at the ls is one of the classics in Unix of just having insane numbers of flags and switches and whatever else. wget is another one. Just look at the man page for wget. It's huge. So, but it only does one thing, and it does it really well. It does it very comprehensively. I don't need to go anywhere else to find file details because ls does that for me. Okay, do one thing and do it well. The other thing that Unix philosophy says is be composable. Right? Have things, and again, as you see, these things are overlapping. So together with composability, there's nothing you can't do. Unix is over 50 years old. I know this because I'm over 50 years old and we're about the same age, right? Unix and I were born within about 6 months of each other. So when Unix turned 40, I was like, oh, here we go. Unix has been around for 50 years. Unix now is Linux, it's FreeBSD and OpenBSD. It is Mac OS, right, is a BSD or a variant of BSD. It's all over the place. Windows now has a Linux subsystem. Okay, because people need, because the world uses Linux to build software on, right? And Docker requires a Linux kernel, okay? And so this Unix 1, right? It's one of the very few things that's been around for that long. Lisp. Lisp is another thing, or variants of Lisp, flavors of Lisp has been around for over 50 years. Again, because it just does one thing well. It's an incredibly simple, small thing. So together with composability, there's nothing you can't do. And so another thing the Unix philosophy says is expect the output of every program to become the input to another. So I can cat, which is just all it does is give me the contents of something. grep searches for patterns in there. Sed transforms those patterns. Sort puts them in an order. Unique, once they're in an order, finds the ones that are different. And so on and so on and so on. That little pipe thing, that's a composer. Okay. And there are programming languages that use that pipe. It's not a coincidence that Go, the Go language, uses that pipe in its template language because the same guy that designed Unix designed Go, or at least was one of the core designers. Rob Pike was at the heart of Unix when it first started, and he's the lead on Go. So Go as a language expresses a lot of these CUPID properties. But isn't that the same as SRP? No. SRP is about how code changes. SRP says code should have one and only one reason to change. Okay, so it's about a property of the code. What the Unix philosophy is about is what you do with the code. Okay, again, it's from a human perspective. So there's our U. So we're composable. We've got Unix philosophy, do one thing well. What's next? Well, the next thing is I want code to be predictable. I think that's reasonable. What do I mean by predictable? It behaves like it's supposed to behave. Okay, I don't want surprises. So Kent Beck has these wonderful, he has his 4 rules of software. And his first one is passes all the tests. Okay, the first thing is passes all the tests. That's great if you're Kent or if you code like Kent, which is you write tests, you write code examples, you then write the code that makes the example work, and you iterate like that. So you write code guided by examples, right? Guided by tests. If you have code like that, then you can define predictability, or a pretty good proxy for predictability is the idea that it passes all the tests. I want something broader than that. So I see predictable as a generalization of passes all tests. I've worked on code bases, particularly a long time ago, before TDD and test first and that kind of mentality became prevalent. And certainly, again, it's culturally different. If you look in C++, there's very little TDD in C++. It exists, but it's not normal. Or in C or in embedded languages, TDD isn't normal. In a lot of scripting languages, TDD isn't normal. It took off in Ruby and in Python. And there's a lot of places where you don't see TDD. In a lot of the Microsoft world, in a lot of the .NET world, it's still not particularly common. However, I've worked on large, really complex C++ code bases, doing things like telecoms billing for pan-European, really big, complex, messy systems. And you get in there, and the code was unbelievably easy to navigate. It was well factored, it was well designed, it was well architected. There was a bug. I was given a bug of someone else's code. This thing is coming out, we're getting these numbers out in this report, it's coming out wrong. And I looked at this, and it took me less than half an hour to navigate the code to figure out where the bug probably was. It then took me about 5, this is no tests, right? It took me about 5 minutes to realize that there was a less than instead of a less than equal in a comparison. And I then changed it to less than equal and compiled it up. And I just sort of mucked around with it, put a few values through it, and it looked about right, and it was done, and it was fixed. I've seen completely test-driven code bases that were an absolute mess, because TDD is brilliant for designing the small. TDD is brilliant for guiding your local design. You need an overarching, again, XP calls it a metaphor, but you need an overarching architecture, right? An architectural vision in order for your test-driven software to build into. So passes all tests is necessary but not sufficient if you've got tests, right? So I want behave as expected. I also want deterministic. So what does that mean? It means it carries on behaving. So passes all test is interesting, but that's a point in time, right? Passes all tests always, continually, right? It does the same thing every time. I can put the same thing in, I can get the same stuff out. And that's not necessarily just behavior. That's operating characteristics. That's it always responds within 200 milliseconds. It deals with this amount of load. It will happily handle 200 concurrent queries. So I want it to be deterministic, because then I can make predictions based on it. And finally, it's observable. And in a technical sense, in the MIPSy-TIPSy, in the Charity Majors sense of observable, in the scientific sense. So observability isn't logging. Right? Observability is I can infer internal state entirely from output. So I can look at how something's behaving, and then based on that, I can tell what's going on inside. And there's an awful lot of software around for which that's not true. So you need instrumentation, you need telemetry baked into the components you're building. Idiomatic. And again, just to reiterate, this is a very, very rapid introduction to CUPID. There are many, many layers to all of these things. My plan is to start blogging and talking about this in a lot more detail. This is just the whistle-stop tour, if you like. Idiomatic means this. It means it uses language idioms. Okay, write code that looks like all the other code. I see too many developers, programmers, and I've been that programmer as well, right? Mea culpa, who come in. So this is how we did Perl in my last place. This is how we did Ruby in my last place. This is how we did Java in my last place. And I just start doing that. and I have no kind of sense of what you're doing here. Or I switched to a new language. I started with Python about 10, 15 years ago or something. And it was a revelation to me. It's such a gorgeous language. The problem I had with Python is it's too simple, right? When you're used to Java, Python is just a kind of like it's the red pill. It's like waking up out of the matrix and going, whoa. So I was writing Java in Python. So all my Python had objects and classes and methods. And then I realized I didn't really need objects and classes and methods. And then I took all those away and just had functions. And then I realized I didn't even need classes, and I could just use packages for namespaces. And suddenly all of my code just went away to about, the 8 lines that I needed. And that's a journey, right? When you go into a new language, you carry the idioms of your existing language. So we're going to use the language idioms. We're going to use standard features. We're going to use standard constructs. How does Python do iterations, do sequences? It mostly uses a thing called list comprehensions. List comprehensions don't exist in a lot of languages, and so they're unfamiliar. Clojure loves recursion, right? Clojure loves recursion. It loves tail recursion. You write for loops in Clojure, you can, but you just don't see them very often because other people don't. So when it feels natural to work with, then you're doing it right, and it goes with the grain. So it's like if you imagine it's wood, and you're trying to work the wood. If you work with the grain, it's much easier. If the code you're building, the code you're integrating, uses the same idioms as the code around it, again, there's less cognitive load. There's less thinking I have to do as a programmer to use your stuff. And it's not just language idioms; it's local idioms. It's what we do around here. So what's our house style? Do we have coding standards, design standards? They're usually not that onerous, right? Go read them, go learn them. Or de facto, just see what other stuff is going on around here. If these people use lots of getters and setters, I know we can all talk about it, but that's what they're doing. If I'm going to write new code, I should make it look like their code. Now, there's a whole other conversation about how you shift those idioms, right? How you shift a very imperative type of code base towards a more functional style or towards immutable data types or tiny types, little classes that represent values, that kind of stuff. Now, going on that journey is itself an interesting exercise, but can you do that idiomatically, and can you do that bringing people with you? Be aware that these design standards may not exist, okay? You can only write idiomatic code if you learn the idioms. So this is about investing in the language or in the tools that you're using, okay? In the frameworks that you're using. And finally, and this is probably the deepest and widest, but they're probably all the deepest and widest, right? Domain-based. So what does that mean? Well, the first thing is it uses a domain language. I contributed to 97 things every programmer should know. My contribution was code in the language of the domain, okay? So think about the language of the domain. If your domain is trading, then you're talking about trades and settlements and counterparties and those things. And those words should appear all over the code, because then it makes it easier to reason about. And remember, there's multiple domains. So if I'm looking at settlements of trades, there's a domain around settling, there's a domain around trading, there's a domain around counterparties. Each of these things are going to have separate sets of vocabulary, sets of actions. But it also uses domain structure. And this is a big deal for me, because so often in code bases, I see framework structure, not domain structure. So I see a folder for models, a folder for views, a folder for controllers, or whatever it might be, DAOs, whatever they might be. And all of those are kind of gathered together in a bucket. I don't care. I don't care about models using controllers. I care about payments and loans and onboarding. I care about the subdomains that my solution uses, okay? So I code for the solution, not the framework. And then the other thing as well is I want to use domain boundaries. So I want to let the bounded context, the subdomains within there, and this all goes back to Eric Evans' brilliant work in domain-driven design. I want to use those domain boundaries as my module boundaries. I want to let the solution, let the domain language and the domain structure inform how I build code and how I structure code and how I shape code and how I deploy code. My units of deployability should be along domain boundaries. And again, I could go deep into this. It's one of my favorite topics. So that's what I wanted to introduce you to today. I think I brought it in reasonably within time. So I was not expecting to do that. So just to recap then, CUPID. right? I want joyful coding. I want code that makes me happy to use. And I want to give you code that makes you happy to use it. So it needs to be composable. It needs to play well with others. It needs to adopt the Unix philosophy of doing one thing only and one thing well. It needs to be predictable. It needs to do what you expect. And it needs to be, I should be able to prove that it does, and not formal proofs. That's a whole nother world. But I should be able to be very confident about what it does and confident about making changes. It's back to Dick Gabriel's habitability. Idiomatic. So low cognitive load, okay? Low inertia to change, right? If I want to change something, I should be able to see what I want to change and know what I want to change it into, and that change should feel natural. And finally, domain-based. So I want it to be domain-based in terms of the language it uses and in terms of the structure it uses. I'm going to be talking about this, writing about this for the next, I don't know, chunk of time. I'm very excited about this. As I said, it wasn't my plan to have this schedule. It wasn't my plan to have this acronym. I'm quite glad that people kind of squeezed it out of me, because now I'm getting quite excited about it. So thank you very much for letting me open your conference. I hope you have a wonderful, wonderful day. There's tons of really amazing stuff, so you're going to have to make choices, I'm afraid. I'm going to hand back to lovely Sebastian. Thank you. Enjoy your day.